Good morning. This is Dave Reitzman with Energy Systems Group. I apologize I couldn't be there with you in person today, so we're going to try this audio recording to get through these two examples of performance contracting with wastewater treatment plants. What we hope today is that these will be the capstone that brings together everything that you've heard today with two examples of how other utilities, both large and small, have utilized energy savings performance contracts to upgrade infrastructure and do it through the Guaranteed Savings Program. Certainly, one of the things that I'd like you to take away with today is not only the technology and the procurement systems, but also how each city dealt with organizational change. Both of these projects represent a different way of doing business for these. In one case, the city of Winchester, it was the first project they'd ever done. In the city of Winchester, this was but a third phase of a series of projects they had done over a series of years. But in each case, there were people within the cities that had some doubts and concerns that had to be addressed. And I think you will try and face similar situations when you go back to your own hometowns and do this. So just as a quick introduction, here's a picture of myself. Again, I'm sorry I couldn't be with you today, but I have some other staff with us that will be able to answer questions you might have as we move through each of these examples. Thank you again for sticking around and participating in this session. We hope it's been a great day for you. Just as a way of giving you an overview to the city of Bloomington, it's a city of about 70,000 people in southwestern Indiana. The facility in question was a 20 million gallon per day wastewater treatment plant, and they had done two previous phases of work, but it was with the city and not with the utility. One of the first things we did is going to the city attorney and ask them to write a letter of opinion if they thought this procurement process could apply to the utility. Back then, the legislation in Indiana did not specifically spell out you could do wastewater work under performance contracting. It didn't say you could, but it didn't say you couldn't either. So we thought there was a pretty good chance that it would apply, and the city attorney agreed with this. And so when we presented the concept of a turnkey delivery system that brought financing and guaranteed performance all together in one package, the utility director was very interested in hearing more how this might apply for them as well. They used a request for proposal process that started in May of 2003. Construction of the project was fairly long, almost 18 months, primarily due to a very long lead time blower that I'll talk about a little bit more in a few minutes. So just to give you a quick overview of the specific timing for the project, we met with the utility staff in February of 2003. We presented them with a feasibility of how this would apply specifically to them at their south wastewater treatment plant in April. And the focus of that project was the aeration system and upgrading their blower systems. The request for proposal was sent out the next month. After selection, we went through a negotiation and verification process to kind of narrow down exactly what they were going to do and what they were not going to do. We went to the utility board for approval, and finally city council later in July, with full contract authorization the following month. Just to give you an idea to how the team was organized, we had a general contractor that was responsible for the bulk of the work, and they handled both electrical, equipment, and we also put the design engineer with them. For that particular project, we thought that that was the best approach for the project. We also had some HVAC and other minor mechanical repairs that we used a local subcontractor to perform. The role of the design engineer was to verify the submittals and overall design characteristics for the project. There was also some changes to the concrete structures in the anaerobic digesters that changed some of the flow patterns, and we wanted the design engineer to approve those and make sure it was all in line for the process of the plant, to make sure it was all done accordingly with proper engineering practices. The Dillman Road facility, here's a kind of a rough process flow diagram, at least from a block standpoint. It's a conventional activated sludge plant, probably 30 years old. The primary clarifiers and aeration basins with finals. After that, the biosolids are all land applied, and they had aerobic digesters. Most of the work for purposes of this project took place up in the second area, in the aeration basin area. So, like most plants of that era, they were built with coarse bubble diffusers. They had not yet converted over to fine bubble diffusers, and because of the smaller bubbles, you get a much better oxygen transfer rate, which allows the biology to work and the BOD and nitrogen to be removed from the aeration systems. This was probably one of the largest plants in Indiana that had not yet converted to coarse bubble. To fine bubble. The advantage here is that with better efficiency of oxygen transfer, you need a lot less air. So we were able to reduce the air supply by almost 50% through the usage of these ceramic disc diffusers. They had 6 aeration basins, and all in total we had over 12,000 of these replaced with complete systems. One interesting note that we have often finded very positive unintended consequences through these projects, and since we typically replace most of the buried piping, we have found a lot of plugging and other deterioration in the piping that you just can't really identify or quantify up front, but there's tremendous savings from removing this and putting fresh, clean pipe in. So here's a great illustration of some of the happy accidents that occur when you're upgrading your plant. They at Bloomington, they had 4 800 horsepower multi-stage centrifugal blowers. And when we reduced the air demand, we did not have the capability to really maximize the efficiency with those existing blowers. The multi-stage blowers are very reliable, very robust technology. They've been around many, many years, but they really pretty much work in an on-off situation and don't have any type of variable flow capability. So one of the things we evaluated and wound up including in the project was a variable vane, variable flow unit manufactured by Turblex. It's now a division of Siemens. And at the time, this was the highest technology, most efficient unit on the market. And the advantage here is that this unit could supply air during low demand periods, and during high demand periods they could base load one of the other units, and this other unit would act as a trim blower to raise and decrease depending on air demand. The key here is that while doing the diffusers, you also need to go back and look at the blowers to maximize the efficiency of the whole blower aeration system. And we were able to take out I think an 800 horsepower unit and putting in a 400 horsepower for a significant reduction in blower energy. Just a few other small units. They had a makeup air unit for the aeration basin. It was an electric unit, and we replaced it with a gas-fired unit. The financials of the project were overall a $2.3 million project with a 10-year payback. We were getting some very good interest rates at the time, so we wound up even refinancing some of their older previous debt, which gave them another $40,000 in savings over the life of the project. Certainly the base project that we looked at had quite a little bit less than an 8-year payback, and performance-wise, the graph in the lower right-hand corner shows you over the last 6 years, while we guaranteed $925,000, they'd actually received $1.1 million. Keep in mind, this facility consumes almost $400,000 a year in electricity back then when we analyzed it. And by implementing this project, we were able to cut their utility bill, I think, almost 25%. So that's $100,000 a year in savings. So this was a significant number, and they saw it immediately on their first electric bill as soon as they got it after the project was over. From a sustainability standpoint, City of Bloomington is a college town, and so they have a very big focus on what their carbon footprint is, and we do annual reports for them that translates what the savings of the project is from electric and gas back to each of the corresponding greenhouse gas emissions. So why did they want to go down this path? When we initially presented this concept to the utility director, I think what intrigued him most was the ability to get an existing project that they had known about for a long time and get it done very quickly, very easily, with trusted advisors, both from a contracting and engineering standpoint, and then having the performance guarantees on the back end bundled with the financing. This turnkey delivery was not something that they had available. They had a preliminary engineering report that identified this fine bubble project probably done 5 years before we got involved. But because they had been so busy with the day-to-day running of a utility, long-term control plans, other maintenance issues, rate increases, all the things that they have to deal with, they just didn't have time to get around to do this needed project that was going to have a lot of financial benefit for them. So this process allowed them to accelerate a project that wouldn't require a lot of staff time to babysit both the development and delivery of it. So that immediately clicked in the utility director's mind as a way to get this thing done and off the shelf and out into the field. The concept of single source accountability was big. They had had a number of projects before that had some cost overruns to them, and it's very difficult to go back continually to the board and present change orders to them. So the concept of a guaranteed maximum price project was, again, another attractive thing to them. It just gave them peace of mind at the end of the day that people were going to do what they said they were going to do. And finally, the last item is not to be missed. There was no rate increases required. The savings could pay for the project without having to go back to the ratepayers and ask for more money to fund this project. So I always ask, would you have done anything differently through the project? I think one of the things that I wish I would have done is add dissolved oxygen control to the aeration system. This was a very large plant, and it would have had a very complicated SCADA delivery system to manage all that. But I think it could have been done. At the time, the plant wasn't sure they were ready, and the design engineer we had wasn't very confident in the oxygen controls, and so it didn't make it through the final cut. We decided to eliminate it and done. I think they've gone back and added it since then, but it's something I think we could have got. So a little more increase in savings. I want to give them better overall functionality of their control systems. The second item was something that came up during startup. Because we had changed the aerators and the aerobic digesters, it changed the biology a little bit during startup, and there was some foaming involved. And if you've ever had foaming in your digesters, it's of concern what the depth of the blanket is and if you're going to overflow. It went away, but it was cause for probably more than a normal amount of concern from the operators and management while this was ongoing on how we were going to deal with it. So I think everyone would have been a lot happier if we could have warned them ahead of time that this was a possible and probable outcome that will be dealt with and faded away. So nobody likes surprises, especially not when you're starting up a wastewater treatment plant. I'm sure that's something you can all agree with. Finally, the last item that happened about a year and a half was an issue with the blowers. And like all problems that often come up, it's never one thing, it's never two things, it's usually three things all coming together to create an issue. And in this case, the blowers have lubricated oil bearings, and so even when the blower is not running, the main power has an oil pump that turns regularly to keep that bearing lubricated. So somebody heard the oil pump running when the unit was shut off and killed the main power to it, which was something that you shouldn't do for that blower. Then, while the other units were operating, it caused air to go back through the unit in reverse fashion and caused the blower motor to turn on an unlubricated bearing, which created a failure. So you might say, could anyone have foreseen this potential to occur? And we thought it could. So we fixed it. There was no cost back to the owner, even though this was out of warranty, and we added a check valve on the outside that would always positively close. So the moral of the story is, one, while it's a bad thing that the blower got damaged, the good news is that it didn't impact the owner, and we had a chance to fix this from an operator training standpoint to make sure they all know they were supposed to keep that main power switch on. Ultimately, I guess my point here I'm trying to make is with performance contracting, folks, we live and die based on positive public relations, and we're only as good as the last job we did. So we couldn't afford to have an unhappy customer. So we had to go fix it. It was in our best interest. This is one of the first wastewater treatment plant projects that went on in Indiana through performance contracting. So the customer had to be happy, and we were going to do anything it took to make sure they were. We hope you will have a similar but better experience when you do one of these projects. So with that, that's all I have to talk about the city of Bloomington. I'm going to pause for a few minutes here for questions, and then we can go into the city of Winchester. Thank you very much.